All right, let's take a look at section 1.2, which is transformations of linear and absolute value functions. As we begin right here, we're going to start talking about horizontal and vertical translations. Now, we use specific variables to notate a horizontal translation. And as you can see right here in this equation that's shown, it says the graph of y is equal to f of x minus h. So h right here will determine which way it is shifting horizontally, which is shifting left or right. Remember in 1.1 I told you that, look, if this part, whatever's in the parentheses, if it's x plus a number, it'll shift our function to the left, to the negative side. If it's x minus a number, it's going to shift it to the positive side, to the right. So that's what they're showing you right here in the graph, horizontal translations. Now, the big thing that you need to understand is that I'm going to be using the term, and you're going to hear it a lot down here, it's highlighted, input. When we talk about horizontal translation, what I'm going to say a lot is that it impacts the input. Now, what is the input? In Algebra 1, if you remember, if we talked about like x and y, we made a table. We said you should have been told that x right here is your input and y is the output. So if you have an equation like y is equal to like x squared, and you started plugging in numbers for x, you would plug it in, and the results would be your output. So if I plugged in 1 for x, the output would be 1 for y. If I plugged in 2 for x, so 2 squared, then your output would be 4. So that's the input and output. So when it comes to horizontal translations, whatever h is, it will only impact the input. That's why what happens is you'll see things in parentheses. So x minus h is in parentheses because that h value is only going to affect the input. When it comes to vertical translations next, we use the variable k to determine whether the function is shifting up or down. And that's what you see right here in the graph that they show you. The difference here is this. For vertical translation, it will impact the output, or what I will say is that it impacts the whole entire function itself. That's why right here it says the graph of f of x. So whatever f of x is, we could say it's x squared, and then you add a number to that or subtract, and then that'll shift it'll impact the whole entire answer, the whole number up and down. And that right there is your vertical translation. If it's plus k, it's going to move up. If it's minus k, the function will move down. Next up right here, we talk about reflections in the x-axis. And right here, when we talk about reflection of the x-axis, the main thing is right here, it impacts the output, the whole entire function. Okay, so right here up at the top, you'll see f of x and then the negative out in front right here. Meaning, whatever our function is, if there's a negative in front of it, then you'll take the graph and you will reflect it across the x-axis. All right, so you can see in bold or in black right here, that is the original function. When you take the reflection of it, it impacts the whole entire function, and then you'll see that it flips it across the x-axis right here. When it comes to the reflection in the y-axis, that is input only. Okay, so you're not going to multiply the entire function by the negative, only the x will have the negative, and that's what they're showing you right here. In parentheses, you have the negative x, and that will reflect across the y-axis. And this example right here isn't the greatest because it looks like it's the same exact thing, or almost the same as reflection across the y-axis. But you can see right here, if I take a look at like the y-intercept, it's reflecting across the y-axis. As opposed to over here, if you look at where the x-intercept is, that's where it's both the same. Now, horizontal stretch and shrinks. We have seen some horizontal stretch and shrinking. If you remember the absolute value problem that was in the notes in 1.1, there was like 5 times absolute value of A. Okay, so, or absolute value of X. Let's not get that confused. Because right here, what we mentioned is the A term. The A term in a function is going to affect whether we have a horizontal stretch or a shrink. Okay, for a horizontal stretch right here, it says if you multiply the inputs by A, then that will stretch it horizontally. Right, so an example of an equation, like I said, what we had right here, for stretch, it was, let's say, y is equal to 5x. Right, that right there would be a horizontal stretch. A horizontal shrink, what it says right here is when the A value is actually less than 1 and greater than 0, that's a horizontal shrink. So for example, y is equal to 1/2 x. Because if you think about our line right here, these are both linear equations. If it's 5x, we go up 5 to the right 1, right? And it's very steep, thinking about as a stretching out. If our for the horizontal shrink right here, it's going to be a lot flatter, right? We go up 1 to the right 2, and there's your horizontal shrink. And then the parent function, up 1 to the right 1, would be in between both of these and would look something like this. So the green would be the parent function, and then you could see horizontal stretch, it's steeper, being pulled up. Horizontal shrink, it's compressing. Think about it that way, compressing. Key term right here, you are multiplying the input, meaning you're only multiplying it to the x value. As opposed to right here, when we take a look at our vertical stretch and shrink, the A value will be impacting the entire function, and then right here, you're multiplying the outputs, as it says. When A is greater than 1, we have a vertical stretch. When A is less than 1, greater than 0, it is a vertical shrink. Okay, so vertical stretch, vertical shrink. And that's when the whole entire function is being multiplied by whatever our A term is. All right, so let's take a look at a few problems here, a few examples. And figure out what's going on, okay, in the extra practice. So for number 1 right here, it says they're asking you write the function g whose graph represents the indicated transformation of f. Okay, now I tend to show each step as far as input and output, and that'll probably help you in the very beginning, especially when we're uncertain of what to do. So we have our function right here is the absolute value of 1/3 x. And it says we have a translation of 2 units to the left. So if it's 2 units to the left right here, that means it's going to be going horizontally. And hopefully we remember that horizontal, that right there, is an impact on our input, meaning it's only going to affect the x. So here's what I'm going to start doing. For horizontal, if it's going to the left 2 units, that means it has to be x plus 2, okay? And what I'm going to do, since that is the input, I'm going to go ahead and take this x plus 2 and substitute that into our function right here. And so I have now 1/3, absolute value of 1/3, and then what I'll plug in right here is the x plus 2 to distinguish, all right, my input has changed, okay? So now once I have that, you can go ahead and simplify this, and let's distribute that 1/3. And so we'll go ahead and change this to g of x is now equal to absolute value 1/3 x, and then 1/3 times 2 is plus 2/3. Okay, so each transformation, what I will tend to do is write the rule on the side. If it's input, then I'm going to show, all right, am I adding or subtracting to the input? If it's output, I'm going to show, all right, what am I going to multiply? I want to multiply the whole entire thing. Let's go to number 2. It says right here we have a translation of 6 units down. Okay, 6 units down right there would be your vertical. And remember, when it's vertical translation, we use the variable k, right? And so, since, remember, vertical translation happens to be output, we're actually going to take our entire function right here, and we're going to have to, if it's going 6 units down, hopefully that makes sense to the fact that we are going to be subtracting 6 units. So I'm going to go ahead and put minus 6 right there. And so in the end, let's go ahead and simplify this. And then we have minus, we'll have absolute value x plus 9, and then -1 minus 6, that gets us -7. And so this right here is g of x, right? Because it's not the same equation, so we don't want to use f of x again. We're going to use g of x to represent the transformation. And the homework says, or the problem says, use graphing calculator to check your answer. And it would be handy if you probably went on Desmos and compared the two equations to justify and see, all right, what direction are things moving in? Especially if you cannot since you can't really visualize, maybe you're having a hard time visualizing what is going on. So right here we have translation 7 units down. That is a vertical, and vertical is output. So we got our equation, -2x plus 2, and we're going 7 units down. So we're going to put -7 because that's going to impact the entire function itself. So now we can go ahead and simplify this. And I've got g of x is -2x minus 5. All right, let's go ahead. We'll probably go through all of them to give you kind of a decent idea of all of the different functions, I guess different scenarios that you're going to be encountering, and there will be a whole lot of them. All right, reflection across the x-axis right here. So x-axis, reflection. If you remember, that right there was input. Okay, so if you need to go back to your notes, x-axis is your output. So if you go back to your notes, remember, that's where you can figure out what's being impacted on all these things. When it's the output, remember, it's the whole f of x is going to be multiplied by negative. So what I'm going to do is let's go ahead and we'll put negative right there, and then f of x is actually your 1/2 x plus 8. And that is the actual function. So after that, we're going to go ahead. It'll be negative 1/2 x minus 8 right there, and that is g of x. For number 5, we have reflection in the y-axis. So y-axis and reflection, that right there is input. Remember, input represents the fact that only the x value will be changing. So I'm going to go ahead and put in parentheses negative x. So inside of our function right here, I've got 4 plus absolute value. And then right here, let's go ahead and substitute that with negative x to represent our reflection in the y-axis. And then we have ourselves plus 1. So if we were to simplify this right here, there really isn't too much to do other than let's go ahead and change this to absolute value negative x plus 1. And there's your function. Number 6, we have a vertical shrink by a factor of 1/5. Remember, a vertical shrink right here tells me that whether it's vertical or horizontal, that is dealing with our a value. So vertical shrink, remember this right here is your a value. I'll put vertical shrink because there is a difference between vertical and horizontal shrink. Vertical shrink is your output, meaning the whole entire function will be multiplied by whatever that factor is. So if our factor is 1/5, we're going to take that 1/5 and multiply the entire function right here, which is negative 5x. We'll go ahead and simplify that, and that right here gets us negative x. And so g of x is equal to negative x, and that is your function. In your homework, and I would like for you to write down whether you have a vertical stretch, vertical shrink, or whatever the transformation is, and write down, is it supposed to be an input or output type of transformation? It's very helpful later on because you're going to see problems where there are multiple transformations in one problem. And so you're going to have to make sure you do each and every step along the way. We have a vertical stretch by a factor of 4. So we got vertical stretch, factor of 4, that right there is your output once again, because vertical stretch, and then that means that the whole entire function will be multiplied by 4. So let's go ahead right here. I'll put 4 out in front, and then let's copy down the entire function. We could put it in parentheses, and I got absolute value x plus 3, and then plus 2. And so what we're going to do is distribute this 4 throughout. Now the 4 doesn't go inside of the absolute value right here. So when I distribute that, I can go ahead and just put 4, and then we'll put absolute value x plus 3. However, this 4 does go to the 2, so that'll change us to plus 8. Because remember, when we say output, it affects the whole entire equation, and this will show that right there. All right, so there is your vertical stretch. What I see a lot of students actually miss is the fact that they'll distribute it to the x at x plus 3, but then they forget that it also impacts the y-intercept of, and that's why that right there turns into 8. Let's take a look next up at number 8. We have a horizontal stretch, and that right there is going to be input. And the big thing with horizontal stretch, if it's a horizontal stretch, you think, hey, let me multiply that by 6. It sounds like it, right? Because stretching is going to be bigger. But actually, what you need to do is take the reciprocal of this. A horizontal stretch is actually going to be a factor of 1/6. Okay, so remember that reciprocal for horizontal stretch and shrink, you must take the reciprocal of that factor. Now, because right here horizontal stretch and shrink happens to impact the input, let's go ahead and I'll put 1/6 x right here. So because it affects the input, I'm going to go ahead in our function, I'll change this to 3, and then we'll multiply that by 1/6 x, and then we'll have -9. And that's how I notate the fact that only the input is being affected. We can go ahead and simplify this, and then we have g of x, 3 times 1/3, that turns into 1/2 x. And then we don't distribute it with the 9 because not everything is in parentheses like it was in number 7. And it's going to be 1/2 x minus 9. And there you go. Number 9 right here, horizontal shrink by a factor of 4. So because this is a horizontal shrink, remember that right there impacts the input, but we take the reciprocal of 1/4, and it's actually going to be a factor of 4, or 4x. Okay, so very tricky, easy to get confused and forget. So let's take a look at our function. We have absolute value of 8, and then now instead of just x, that'll become 4x right here. Minus 4. Okay, so once again, this will show you that only the input is being affected, and so this will turn into negative absolute value. 8 times 4x is 32x, and then we have ourselves minus 4, and there you have your function. All right. Have a little bit, let me go over one more thing right here. Let's take a look at number 10. This right here says write a function g of x that represents a reflection of the x-axis followed by a horizontal stretch by a factor of 3 and a translation of 5 units down. Okay, you've got to do this step by step. All right, one by one. Don't go out of order. Okay, so when you look at these problems, let's start off right here. We have a reflection of the x-axis. Okay, so if it's x-axis reflection, remember that right there is output. So that means that the whole entire thing, function will be impacted. So it says a reflection across the x-axis. Let's go ahead and start off. We've got f of x. Because the whole entire function will be impacted, let's go ahead and set that equal to, and then I'll put negative right here in front, and then we have absolute value of x. Okay, so there's the first part. Step 2 says it's followed by a horizontal stretch. So we have horizontal stretch, and that right there is going to be your input. It's a horizontal stretch by a factor of 3, so don't forget that we can't just put 3 down. This has to be 1/3. So we'll go ahead and change that to 1/3 x. So let's take a look at the function we have right here, and then we have ourselves negative absolute value, and then we'll substitute that x with our new input, which is 1/3 x. And then finally, there's a translation of 5 units down. Okay, so 5 units down, that right there is a vertical transformation. That right there, once again, when it's vertical, it is output. So I'll go ahead and put that right there. And then if it's 5 units down, it's going to be -5. So let's finally take our function, and then we have g of x right here is equal to negative absolute value 1/3 x, because it's everything from this previous step, and now we'll include -5. And so this right here is your transformation. All right, if you have any difficulties, make sure you come to tutorial. All right, and I will see you later.